Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Friends, in this video we'll discuss question number 15, NEET Physics paper 2016. Student, in this question number 15, we have when a metallic surface is illuminated with radiation of wavelength lambda, so this metal surface is radiated with wavelength lambda, the stopping potential is V. So here the stopping potential is V. The same surface is illuminated with another wavelength. Suppose when it is radiated with wavelength 2 lambda, and stopping potential is V by 4. The threshold wavelength for this metal, so you have to find lambda naught for this metallic surface. The equation that is used for this is Einstein's photoelectric equation. Photoelectric equation, which is the energy that is incident is used up in the work function of the metal plus the kinetic energy max of the photoelectrons. So from here, in terms of wavelength, I can write this as hc over lambda is hc over lambda naught plus k max. K max is related to, this is K max, is E times V stopping potential. So this K max can be written as, in other words, I write K max is the hc by lambda minus hc by lambda naught. Okay, this is nothing but EV stopping potential hc over lambda hc over lambda naught. I have to use this equation 2 times, one for the wavelength lambda and one for the wavelength lambda. This equation becomes EV because stopping potential is V in this situation, and this is hc by lambda minus hc over lambda naught. For the second situation, when this is 2 lambda and the stopping potential is V by 4, so it is lambda and V, and it is 2 lambda and V divided by 4. V is V by 4. This is hc by lambda is 2 lambda here minus hc over lambda naught. So these are the two equations we are getting. If I say this is equation 1 and 2, then I will divide the equation 1, dividing equation 1 and 2. We get first is EV divided by EV divided by 4, and this side it is hc by lambda minus hc over lambda naught divided by hc over 2 lambda minus hc over lambda naught. So this will be 4, and this is equal to hc being common out, this is 1 by lambda minus 1 by lambda naught divided by 1 by 2 lambda minus 1 by lambda naught. So I had to use that equation, cross multiply that. So it is 4 times this will come to this side. This is multiplied with 4, so this is 4 times this value, which is 1 over 2 lambda minus 1 over lambda naught, bracket closed. This equals to 1 over lambda minus 1 over lambda naught. Okay. If I solve this, then if I multiply 4 throughout, then this is 2 by lambda. This implies 2 by lambda minus 4 over lambda naught equals to 1 over lambda minus 1 over lambda naught. Okay. This implies that I want lambda naught, actually threshold wavelength. This lambda naught is threshold wavelength. Threshold wavelength. So I'll keep this side. I'll bring this side to this side, and this will I'll bring to the other side. So it is 2 lambda minus 1 over lambda equals to 4 by lambda naught minus 1 over lambda naught. This implies 2 minus 1 by lambda equals to 4 minus 1 by lambda naught. So this means it is 1 by lambda. This implies 1 over lambda is equal to 3 over lambda naught. So that implies lambda naught is equal to 3 lambda. So if I use the equation, then you can see this question is about the threshold wavelength, that is lambda naught for this metal, and that comes out to be lambda naught comes to 3 lambda, which is equal to this. So therefore question number 15, option number 1 is the correct answer. Okay, thank you.